Hey everyone, ready for this? We're diving into something pretty mind-blowing today. The idea of a dark Big Bang. Yeah, you heard that right. A dark Big Bang, a concept that could completely change how we see the universe.
It's exciting stuff.
You've probably heard about the Big Bang, right? But what if I told you there might have been another bang, a separate one, that created dark matter?
And that's what's so fascinating about this dark Big Bang idea. It really challenges how people think about the Big Bang itself. Even some science people get this wrong, which is kind of crazy.
Okay, so let's break this down a little. We often think of the Big Bang as the moment when, like, everything just appeared.
Hmm.
All the matter, everything. But it wasn't really like that, was it?
Nope, not at all. The Big Bang, the way we understand it from Einstein's theories, that was the birth of space-time, like the fabric of the universe itself. But when matter was created, the stuff that makes up you and me and planets and stars, well, that's a whole other story.
Oh, interesting. So if the Big Bang wasn't the start of matter, then where did all that stuff come from?
That's the million-dollar question. Right now, theories point to something called the inflaton field. Picture it like a vast ocean of pure energy in the very early universe. As this field changed, it decayed and its energy transformed into particles. Some particles we know, the ones in stars and planets, and also dark matter, the stuff we can't directly see.
Whoa, so it's like the inflaton field had the recipe for everything.
Oh, yeah,
But the
come.
dark Big Bang theory, that throws a wrench in things, doesn't it?
You got it. It says dark matter wasn't made at the same time as the regular matter we see. It had its own separate baking moment later on, coming from another hypothetical field, decay.
Okay, so two different fields, two different baking moments. But hold on, this other field, the one for dark matter,
Yeah.
it's called F. Seriously, F. That's the name.
Yeah. F.
They couldn't come up with something a little more, I don't know, exciting. F just seems so bland for something so potentially huge.
Yeah, I know what you mean. It is a bit odd. Maybe it reflects how little we understand this field, you know? We're still figuring out dark matter itself, what it really is.
Right. We know it's out there because of its gravity,
Uh-huh.
how it affects galaxies and all that.
Exactly.
But we haven't actually seen it directly. It's like trying to study a ghost that only interacts with the world through, well, gravity.
You're getting it. For a long time, scientists thought dark matter must interact with normal matter in other ways, not just gravity. So they built these super sensitive detectors hoping to catch it, interacting. But so far, nothing.
And that's what leads to the, what is it, the nightmare scenario.
Yeah,
What if dark matter only interacts through gravity?
right. If that's the case, studying it becomes incredibly tough. But that's where the dark Big Bang theory gives us a little bit of hope, even in this nightmare scenario.
Hold on. How can a theory about another bang help us understand something as elusive as dark matter? This is where things get really interesting, right?
Well, it's all about gravitational waves.
Mhm.
You see, if this dark Big Bang happened, it would have been this huge energetic event. And it might have left these ripples in space-time itself.
Oh, right. Gravitational waves. Those are like cosmic ripples, right? They travel at the speed of light. And they're caused by some of the most powerful events in the universe. We've already detected them from black hole collisions, which is just mind-blowing in itself.
Yeah, exactly. And the cool thing about this dark Big Bang is it might have made gravitational waves with a unique fingerprint, something that sets them apart from other events in space.
So not just any gravitational waves, but ones with a specific signature. A signature that could point right back to the creation of dark matter.
Precisely, the theory says that as this F field decayed, it would have gone through a phase transition, kind of like when water boils and turns from liquid to vapor.
I'm picturing these dark matter bubbles crashing together and releasing tons of energy, sending out these gravitational waves like ripples in a pond, a cosmic pond.
That's a great way to think about it. And if we could detect those specific gravitational waves, it would be like listening to the echoes of the dark Big Bang, even if dark matter only interacts with everything else through gravity.
Wow, that's incredible. So we could use sound to map out a hidden room, even if we can't see inside. But how would scientists even start to search for those echoes? Wouldn't they be super faint after billions of years?
You're right, it would be a huge challenge to detect those ancient gravitational waves, but we've got some amazing tools now, like LIGO and Virgo. These gravitational wave detectors are sensitive enough to pick up those faint ripples in spacetime.
Yeah, I've heard of those. Those detectors have already changed how we understand black holes and neutron stars. It's amazing, but could they really pick up something as old and faint as the gravitational waves from a dark Big Bang?
It's possible, and even more sensitive detectors are being planned, like the Einstein telescope and LISA. These will be able to see deeper into the universe and maybe pick up even fainter signals.
Yeah. So there's a chance that these future detectors could actually prove or disprove the dark Big Bang theory. That's really exciting.
It is exciting, but I do want to add a note of caution. It's thrilling to think we could detect these waves, but it's important to remember this is still a pretty speculative area of research.
Right. You mentioned earlier that you're always a little bit skeptical. You said there's a trend in theoretical physics that you're a bit concerned about. Can you explain that a bit more?
Sure, you see, there's this appeal to coming up with these big, sweeping theories that could explain some of the universe's biggest mysteries. And while I admire that creativity, I also think it's super important to keep a balance between coming up with those theories and actually being able to test them.
So it's one thing to have a beautiful theory on paper, but it's another to actually put it to the test and see if it matches up with the evidence right.
Exactly. And with the dark Big Bang, it's a really cool idea. But we have to be careful not to get carried away by all the hype. We need to ask ourselves, are there other explanations? What else could have made those gravitational wave signals? And what evidence would actually convince us that this dark Big Bang happened?
So it's like being a detective, but a cosmic detective. You're sifting through all these clues, trying to find the most likely explanation. But you can't jump to conclusions based on one interesting possibility.
That's a great way to put it. And to be fair, the dark Big Bang theory is more than just a cool idea. It's a hypothesis that we can test. We can predict how strong those gravitational waves would be, what their frequency would be, and future detectors might actually be able to detect those signals.
So you're saying we need to be critical, but we also need to be open to the possibility that it could be true.
Exactly. That's what makes science so awesome. It's about constantly questioning, testing, and refining our understanding, sometimes even admitting we were wrong. But the pursuit of knowledge, trying to understand the universe and our place in it, that's what really matters.
Okay, so where do we go from here? What are the next steps in this cosmic detective story?
Well, the first thing is to keep pushing the limits of what we can observe. We need more sensitive gravitational wave detectors, ones that can see deeper into the universe and find even fainter signals.
And while we're waiting for those new detectors to be built, I bet theorists are busy refining their models, trying to predict exactly what those signals might look like.
Absolutely. There's lots of work happening on the theoretical side, too, exploring different ways that dark matter might have been created in the early universe.
It's all very exciting, but I have to admit, I still can't quite picture what this dark Big Bang would look like. Can you paint a picture for us, for our listeners, of what might have happened billions of years ago?
Sure, imagine the early universe. It's incredibly hot, incredibly dense, and then there's this F field, this sea of energy everywhere. As the universe expanded and cooled down, this field became unstable, like water reaching its boiling point.
Okay, I can picture this simmering sea of energy.
Good. Now imagine bubbles forming in this field. Bubbles of a new phase, a new kind of matter. These bubbles would have been full of dark matter particles, and they would have expanded quickly, bumping into each other and merging.
So like a cosmic bubble bath, but with dark matter bubbles.
That's a great way to visualize it. As these bubbles collided and merged, they would release enormous amounts of energy, sending out those gravitational waves that rippled through space-time.
Wow, that's an amazing image. But I'm still trying to wrap my head around these dark matter bubbles. Would we have been able to see them? Would they have interacted with the regular matter that was also around in the early universe?
That's a great question, and it goes right to the heart of why dark matter is so mysterious. We call it dark because it doesn't interact with light, so we wouldn't have seen these bubbles in the usual way.
So invisible bubbles, like phantom bubbles, expanding through the early universe.
Exactly. And because dark matter only interacts weakly with regular matter, these bubbles would have mostly passed right through each other, like ghosts passing in the night.
It's mind-blowing to think about all of this. That this invisible stuff, this dark matter, could have played such a big role in shaping the universe we see today.
It really is, and if this dark Big Bang theory is right, it means we're only just starting to understand the full story of creation, the whole amazing dance of matter and energy that created everything around us.
It's incredible to think we might be on the verge of unlocking some of these cosmic secrets. It feels like we're standing at the edge of a vast, uncharted territory.
I completely agree, and who knows what amazing things we'll find as we explore deeper into the universe.
So we're back, and we've been talking about this mind-blowing idea of a dark Big Bang, a separate event from the Big Bang, the one that might have created dark matter.
Yeah, and as we've been discussing, this dark Big Bang could have left behind traces we can actually detect. Gravitational waves, those ripples in the fabric of space-time.
It's like we're trying to listen for echoes of a symphony that happened billions of years ago, a cosmic symphony. But what would it mean if we actually heard those echoes? Would it change how we understand the universe?
Oh, absolutely. It would mean the story of creation is even more complex than we thought. It means the universe went through multiple phases of creation, not just the single Big Bang.
So it's like finding out your favorite book has this hidden chapter, a chapter that changes the whole story.
Exactly. And it would also tell us that dark matter isn't just this passive stuff just hanging around. It had its own dramatic beginning, its own creation event that shaped the universe.
And you know what else? It solves the nightmare scenario we talked about. If dark matter only interacts through gravity, these gravitational waves might be the only way we can really study it.
Right, exactly. These waves could tell us so much about dark matter, its temperature, its density, how it went from energy to particles.
So it's like finally being able to turn on the lights in a dark room, we'd get to see this invisible stuff.
That's a great way to think about it. And who knows what else we'll discover? Just like when we found gravitational waves from black holes and neutron stars, it opened up all these new areas of research. Detecting these primordial ripples from the dark Big Bang could lead to discoveries we can't even imagine right now.
It's pretty overwhelming to think about all the possibilities.
hmm
But as we've been discussing this, it makes you think about some really big questions. Questions about the very nature of reality itself.
Oh, for sure. If there was a separate event that made dark matter, you start to wonder, right? Could there have been other bangs, other creation events that made even weirder types of matter or energy, stuff we haven't even detected yet?
Makes you realize the universe is even bigger and more mysterious than we thought. And it makes you wonder, are our current laws of physics just a tiny part of a much bigger picture?
That's what's so great about science, isn't it? It's all about exploring, discovering, pushing the boundaries of what we know, and sometimes admitting when we were wrong.
Well, as we wrap up our deep dive into this dark Big Bang mystery, I want to leave you with one last thought. Imagine we could travel back in time and actually see this dark Big Bang happening. What would it look like? What would it feel like to be there, surrounded by the creation of dark matter? Would it be silent and invisible? Or some incredible display of energy and light?
That's a question we probably won't be able to answer for a long time. But let your imagination run wild. Think about the possibilities. Let this mystery fuel your curiosity about the universe.
Who knows? Maybe someday, thanks to scientists and our own human curiosity, we'll be able to figure out the whole story of the dark Big Bang and uncover all the secrets it holds.
Until then, the universe is out there waiting for us. A vast and mysterious playground full of amazing things just waiting to be explored.